Section 13.9, Multiplication and Division with Complex Numbers. The objectives: multiply with complex numbers, divide with complex numbers, simplify powers of I. Example 1, find the following products. A, 3i times the quantity 2 minus 7i. So using the distributive property, we take 3i times 2, which gives us 6i. We take 3i times negative 7i, which gives us negative 21i squared. 6i minus 21 times, we replace I squared with negative 1. Remember that I squared is negative 1. So that's 21 plus 6i. Again, standard form. We put the imaginary part at the end. Example 1b, we have the quantity 5 plus I times the quantity 2 plus 6i. When we distribute, we have 5 times 2 plus 6i plus I times 2 plus 6i, which gives us 10 plus 30i plus 2i plus 6i squared, which gives us 10 plus 32i minus 6. Again, remember I squared is negative 1. Negative 1 times 6 is where we get the negative 6, which, simplifying further, is 4 plus 32i. Example 1c, we have the quantity square root 2 minus I times the quantity square root 2 minus I, which is equal to the square root of 2 squared minus square root of 2 times I minus square root of 2 times I plus I squared. Again, foiling, distributing, whatever you like to call that. Simplifying, the square root of 2 squared is 2. Collecting like terms, we get negative 2 square root 2i, and then I squared is negative 1. Then we have 2 minus 1, which gives us 1 minus 2i square root 2. Example 1d, we have the quantity the quantity negative 1 plus I times the quantity 2 minus I. So when we distribute, we have negative 2 plus I plus 2I minus I squared, which is negative 2 plus 3I plus 1, which is negative 1 plus 3I. This is a common error that you need to be careful of. Remember that the square root of a times the square root of b is the square root of ab, only if a and b are non-negative real numbers. Applying this rule to negative real numbers can lead to an error. The error can be avoided by first changing the radicals to imaginary form. So the wrong solution here would be to do negative square root of 6 times negative square root of 2 and turning that into the square root of negative 12. Which would end up being the square root of 4 times the square root of 3, which would be the square root of 2 times the square root of 3. The correct solution is to turn those into imaginary numbers. So and square root of negative 6 becomes the square root of 6i. The square root of negative 2 becomes the square root of 2i. And then we can multiply the radicands together, and that gives us the square root of 12. And then I times I is I squared, which gives us 2 square root 3 times negative 1, which is negative 2 square root 3. Writing fractions with complex numbers in standard form. Here's your step-by-step process. Step 1, multiply both the numerator and denominator by the complex conjugate of the denominator. Step 2, simplify the resulting products in both the numerator and denominator. Step 3, write the simplified result in standard form. Example 2, write the following fractions in standard form. 2a is 4 over the quantity negative 1 minus 5i. The complex conjugate of negative 1 minus 5i is going to be negative 1 plus 5i, so I'm going to multiply my numerator and my denominator times that amount. So I will now have 4 times negative 1 plus 5i in my numerator, and in my denominator I will have negative 1 minus 5i times negative 1 plus 5i. In my numerator, this becomes negative 4 plus 20i. And in my denominator, I end up with negative 1 squared minus 5i squared. Still have negative 4 plus 20i in my numerator. Negative 1 squared is 1, and subtracting 5i squared is plus 25. This ends up giving me negative 4 plus 20i all over 26. Breaking that apart, I have negative 4 over 26 plus 20 over 26i. Reducing that, I end up with negative 2 over 13 plus 10 over 13i. Example 2b, we have the square root of 3 plus I over the square root of 3 minus I. The complex conjugate is going to be the square root of 3 plus I, so I'm going to multiply numerator and denominator times the square root of 3 plus I. My numerator, that ends up giving me 3 plus 2 square root of 3i plus I squared over, and then in my denominator I have the square root of 3 squared minus I squared. Simplifying my numerator, I have 2 plus 2 square root of 3i over, my simplified denominator is 3 plus 1. This gives me 2 plus 2 square root of 3i over 4. Breaking that apart, that gives me 2 over 4 plus 2 square root of 3 over 4i. And reducing, that gives me 1/2 plus square root of 3 over 2i. Example 2c, I have 6 plus I over I. The conjugate of that is negative I, so I'm going to take numerator and denominator times negative I. The reason is, since I is 0 plus I and negative I is 0 minus I, the number negative I is the conjugate of I. So distributing in the numerator, I end up with negative 6i minus I squared over negative I squared in my denominator. In the numerator, that ends up being negative 6i plus 1, and in my denominator, it ends up being 1. Because I squared is going to be negative 1, opposite of negative 1 is positive 1. So the solution here is 1 minus 6i when I break it apart. And again, you need to put it in standard form. Example 2d, we have the square root of 2 plus I over negative square root of 2 plus I. The conjugate here is going to be negative square root of 2 minus I. So I'm going to take numerator and denominator times negative square root of 2 minus I. When I distribute in the numerator, I have negative square root of 2 squared minus square root of 2i minus square root of 2i minus I squared. And my denominator becomes negative square root of 2 squared minus I squared. Simplifying my numerator a little bit, I get negative 2 minus 2 square root of 2i plus 1. Simplify my denominator a little bit, I have 2 plus 1. Then my numerator becomes negative 1 minus 2 square root of 2i over 3. Splitting that into individual pieces, I end up with negative 1/3 minus 2 square root of 2 over 3i. Example 3 is simplify each power of I. So 3a is I to the 45th power, which is I to the 44th power times I, which is I to the 4th power to the 11th power times I, which is 1 to the 11th power times I, which is I. I is equal to 0 plus I in standard form. Example 3b, I to the 58th power is going to equal I to the 56th power times I squared, which is equal to I to the 4th power to the 14th power times I squared, which is equal 1 to the 14th power times negative 1, which is equal to negative 1. Remember, negative 1 is equal to negative 1 plus 0i in standard form. Example 3c, I to the negative 7 is equal to 1 over I to the 7th, which is equal to 1 over I to the 7th times I over I, because we still don't want to leave complex numbers in the denominator. This is going to equal I over I to the 8th, which is I over 1, which is simply I. I is 0 plus I in standard form.